So for your quiz on rational functions, I would just write down kind of our 4 steps. 1, 2, 3, 4. You could write the steps down. I don't know why this is so. Why can't you see this? Can you see that now? Okay. The 4 steps, and then like on the back page, you could put an example if you wanted to, like actually doing the steps. This could be the rough draft of your note card, and you could put it on something else. But last time I had students make it on their own and half of them forgot. So step 1, how do you find your y-intercept? What do you do first? Plug in 0, 4, x, and solve, right? So step 2 is to find your x-intercept. What's the shortcut for finding your x-intercept? Set the, yeah, you're plugging in 0 for y, but what's the shortcut? Because the denominator gets multiplied to the other side, so you actually have 0 equal to your numerator. So you're going to set your numerator equal to 0 and solve for x, right? Step 3 is going to be your vertical asymptote. How do you find your vertical asymptote? Set the, so where are those bad values coming from? It also helps to find your domain if you want to write that under vertical asymptote, right? You find your domain or your vertical asymptote where? Yep, so you're going to set your denominator equal to 0 and solve for x. All right, and then step 4 is your horizontal or your slant asymptote. So horizontal or slant is kind of that 3-step, A, B, or C. So you compare your numerator. Once you set your numerator by itself equal to 0 and your denominator by itself equal to 0, you're going to compare the numerator versus denominator, right? Numerator versus the denominator. So what happens if the numerator is higher? What do you need to do if the numerator comes out higher? You do division to find your slant asymptote. And you could elaborate more on this if you want an example for each one or whatever, but at least this is the bare bones. B, what if the numerator and denominator are equal in powers? Then what would you do? Yep, so you're going to take the coefficients of x, and like, let's say y equals 2/3, for example. So that's a horizontal asymptote, like if it was 2x over 3x. And then part C, if the denominator is higher, what is always going to be your asymptote? So if you have like x squared in the denominator and that's going to blow up real big, then you're going to approach 0, because a small number divided by a big number approaches 0. And then maybe I should also write down step 5. So if you have room on the front, if not, put it on the back. But step 5 is kind of, we should be looking for holes, right? So the only time, why is it, there we go, a hole. So if you have a common factor, so you should probably check first, right? If you have a common factor, let's say you had x plus 1, x minus 3 over x plus 1, x plus 5. So I have a common factor in this rational function. I cancel my x plus 1s. How do I find the hole? What's the hole going to be at? Yep, so the 0 was -1, right? So we're going to plug -1 into the new function, right? So it would be -1 minus 3 on top and -1 plus 5 on the bottom, and then see what that is equal to. So -4 over 4 would be, happens to be -1, -1, but the x value doesn't always come out the same as the y value. So just at least you have an example of finding a hole. I think that's pretty much what you need, as long as you can understand that shorthand. If you need to elaborate a little bit more with like an example of each, you could go back to number 21. 21 had like one-off questions like find the x-intercept of this, find the y-intercept of this, you know, find the slant asymptote of this. So if you want to make a more elaborate note card, you're welcome to, just so that on the quiz, you're practicing the skills, but you don't have to have every single thing memorized. But for Thursday, the idea is, you know, here's a function, do the steps. And we're going to practice again today and tomorrow. Any questions on that? So you've got your note card for the quiz, but you're not going to have a calculator. So you've got your note card, but not a calculator. Okay. So I wanted to use the note card with you to do example 9 together and then give you a little bit of time to do 7 and 8, just to kind of, you know, get your brain back into rational functions. And then we've got some practice to do on 19. And then I can't remember if we did the multiple choice on 21 or not, but we might do that at the end after we walk. So I tried to put this in order. So my first step is to find the y-intercept. Does everyone have this page? Because I could get you a copy. We're all good. So this is from 18. This should be our last page, 7 through 9, that we haven't done yet, right? How do I find the y-intercept? Look at my note card. I plug in 0 for all the x's. So do I get 0 or do I get undefined? What do I get when I plug in 0? Right, because I get 0 divided by positive 1. So 0, 0 is my y-intercept. What's my strategy to find my x-intercept? I set the numerator equal to 0. So obviously that's also going to be 0. So plug in 0 first, set the numerator equal to 0, check out the denominator. Where's my undefined value for the denominator? At 1, so x equals 1. Some of you on your quiz were still not writing down coordinates and equations. So I don't know, maybe on your note card you want to write down like how to write an x-intercept and a vertical asymptote, if that's something that you missed. Maybe look back at your quiz just so that you have an example of how to write the answer correctly on there. All right, so there's my vertical asymptote at 1. And the numerator wins, and it's higher by only a power of 1. So I guess that's something I didn't put over here. The numerator can only be higher by a power of 1. So if you're taking like x cubed and you're dividing by a linear function, you'd get x squared. An asymptote, the quotient shouldn't be x squared. It should be a linear function, because or else there just would not be a slant asymptote. So if this was x squared, and this was just x minus 1, you would just say there's none. But because this is x cubed and this is x squared, when I do the division, I'm going to get a quotient that is linear. So asymptotes are lines. So make sure that you're going to get a line. So when I'm going to divide this, I actually want to FOIL this out and put the denominator in standard form first. So if I multiply the binomials x minus 1 times x minus 1, I'm really taking x cubed and dividing by x squared minus 2x plus 1. So your divisor has 3 terms in it. So when you set up your box, your 3 terms are going to go down the left-hand side of your box. So you have a little bit bigger box this time. This is x squared minus 2x plus 1. So this trinomial is your divisor. That goes on the left-hand side. And your dividend is just x cubed, right? You actually have 0 x's, or sorry, you have 0 x squareds, you have 0 x's, and you have 0 constant terms coming after it. So inside this box, all that you should end up with when you add everything together is x cubed. So x cubed goes in the top left. And now what goes above the box? This is going to be your quotient. So the first term of my quotient is x, linear function. So x times x squared is x cubed. Now I fill in these bottom 2 boxes. So I have negative 2x squared and positive 1x. So remember, I said I wanted 0x squared up here. So what goes in this next diagonal box so that that adds up to 0? Right? Right. This needs to be 2x squared right here so that positive 2x squared and negative 2x squared adds up to the 0x squared in my dividend. So now I can finish my quotient. I know that the answer is 2 up here because 2 times x squared is 2x squared. So my slant asymptote is just y equals x plus 2. I found it. If you want to find the remainder for practice, this would be what? Negative 4x and 2. And this triple kind of diagonal would have to add up to 0 x's. So this would have to be 3x, right? Because I have 1x and 3x and negative 4x is 0. And then this would have to be negative 2, so that 2 plus negative 2 is 0. This is called your remainder right here. The 3x minus 2 is your remainder. But you don't really need your remainder, just knowing that there is a remainder is important. Or else this should have canceled with a hole. So graphing this line, I start at 2 on the y-axis, and I just go up 1 over 1. So here's my slant asymptote. Here's my vertical asymptote. I can already see where this part of the graph is. It's kind of in this bottom region, so it must kind of go up through here and come back down, right? I think. Sometimes there's funky curves at 0, so let's check. This would be a calculator question if I asked you to actually graph the whole thing, because sometimes these cubic functions behave weird. So let me see. Oh, wait a second. That doesn't look right. Oh, I didn't put my divided by sign. Oh, so it did do a weird thing. So this part of the graph behaved asymptotically, and then see how this part actually shot up and became positive. So there was an x-intercept. It does behave asymptotically because here it's approaching that asymptote, but sorry, misled you. I wouldn't give you one of these that you'd have to graph by hand on a quiz or test because, you know, how are you supposed to know that you have to check on either side of 0 and plug in a point? Usually if it's down in this region, it's down in this region, but that was a weird one because it had a cubic divided by a quadratic. So that would be a graphing calculator for the graph part, but answering these 4 questions, you should be able to do okay. So you're going to try 7 and 8. I don't think you've had time to do these yet, right? So you're going to try 7 and 8 for a minute? Okay. And then we'll come back and put the answers up in a minute. So we had a y-intercept of just 1, because 1 divided by 1, and an x-intercept in the numerator of -1/2. Denominator was bad at -1, so I had vertical at -1. And then the powers were both linear, so I stripped the coefficients, 2x divided by 1x. So y approaches 2. My domain and range are what x cannot equal, so they get that slash through as part of their equation. And then the only point that I didn't know, I knew that this elbow was in the bottom right for my intercepts. I plugged in the point -2 for x. So I plugged in -2 up here, calculated it out, and got +3. So that's how I knew my elbow was in that top left. And then the limit analysis part, as x goes to infinity, that's talking about this arrow. See how that's approaching 2 as a y value? As x goes to -infinity, so that's talking about this arrow. It's approaching 2 as well. As x approaches -1, that's the vertical asymptote from this is from the right side because positive means right. So that's going downwards towards -infinity. And then from the left, this is talking about the left, it's going upwards towards +infinity. So see if you can use what you did correctly or incorrectly on 7 to help you with 8. For look. All right, so I'm just doing this for the sake of the video too, but here's what mine looked like. So it had an intercept at 1 divided by 4, so there's y-intercept at a fourth. No x-intercept because the numerator can never be 0. My asymptotes, this factors into a perfect square trinomial, so it's the same factor twice, so it only has one vertical asymptote at +2, and the denominator is bigger, so y equals 0 is my horizontal asymptote. And then I plugged in the point 3. When I plugged in 3, I got +1. So this is a volcano-looking graph. The reason being, if I write this as a perfect square trinomial, this denominator is never going to be negative, right? A square can never be negative. So you always have a positive divided by a positive. So you're never going to get any negative y values. So that's why your range is y is strictly greater than 0. So I sometimes wait till the end to do my domain and range, because otherwise you might have said y cannot equal 0 just looking at the horizontal asymptote. If you wait till the end, then you'll see, oh, this was a volcano. Y is always above the x-axis. So if we do our analysis, the right and the left sides of the graph are always getting closer to 0, it looks like, because that was the horizontal asymptote. And then both the right and left-handed side are pointing towards positive infinity this time as you approach that asymptote at 2. So positive infinity both times. So maybe this end behavior one was a little bit easier to see because, the right and the left side are the same for that one.